attend the class. Okay, so do you see this? Do
Yes.
you understand it? It's a stoichiometric map, but it's very, very small one because we have just two compounds, one reactant and one product. We have A and we have the product B. If we have mass and volume and particles, we still didn't study this. We have still to study this. And we have small things. We have to finish it. And this is the mole ratio. I don't know. I just want to show you when we make a PowerPoint, I like these designs. Okay? Sometimes for the mole, for the stoichiometric. Already we have the stoichiometric, good ones. So if Safa and Abbas already do their PowerPoint about acid and base, and I don't want them to do double. Even this is a class and that a class, but still, Abbas and Safa, you have to change that PowerPoint, and you have to represent in the front of a grade 11. But you have to you are doing acid and base. You have to include the pH. You have to include the Ka. You have to include other things regarding grade 12. But regarding grade 11, it's just the properties of the acid base, how to test the acid and base, and the Arrhenius and pronosted theory. I will explain them now. So this is what you have to include in grade 11. Do you understand me?
Yes.
Okay, so it just will be small part, less than half of your presentation for grade 12. It will be for grade 11. So I think, no, you have to just do another one. You to cut apart from it. Just you have to open the PowerPoint as I usually sometimes do when I need a PowerPoint. Just I deleted I first I save it by another name. I said save as grade 11 and start delete the pages that I don't need, and maybe add one or two more pages to make it fix grade 11. Because sometimes I use the same PowerPoint for grade 11 and 12. For example, in this lesson, the acid base, I use the same PowerPoint for grade 11. This is the one that I use it for grade 12. I use it for grade 11. About the acid and base and these laws, the three laws that I am going to teach you today. It's not opening with me. Okay, so I will go to explain it. It will be about, I don't know why it's not, I stop sharing. I will open my whiteboard and then I will upload a YouTube. It will be good. That will cover everything regarding what I am saying. Sorry, because I am half sleepy, half tired. It's so I don't know if things will go okay today. Hopefully you will understand me. This is the last day, Alhamdulillah, that we did it and we finished everything. Acid base. What do we mean by acid? What do we mean by base? Already we explained what are the properties of acid and base. So for those who are going to prepare for the acid and base, they have to prepare for me the properties of acid and base. Properties of acid and base. And please, Abbas and Safa, when you do acid and base properties in the internet, you have a variety, okay, of acid and base, sour, good conductors. You have this table, you have to do this table, and please, the other slides give us examples. Do you know? For
Yes.
example, when you are saying sour, you have to bring for us the image of a lemon, because the lemon is acid. When you are talking about the base, we need the image or a pictures for detergents. When you are saying it's reacted with metals, we need this equation that's showing us the reaction with metals and the liberation of the gas, which is hydrogen, and the test for this hydrogen. Okay? There are some YouTubes that already I uploaded to grade 11, 12. Okay? So you have to use that for the properties of the acid. And then you have to tell us how to test if our solution is acidic or basic. Our solution is acidic, we have, or even basic, we test it by the meter. I explained this as before. Grade 11. I explained this or I didn't?
I don't see anything. I just see the title.
No, I didn't. I ask you. I explained how to test acid and base before. Do you still remember?
I think you showed us videos.
Yeah, and I show you some pictures for the meter,
Yeah.
for the acid litmus paper, for the colors. This is a pH scale.
Mhm.
Do you still remember? So how to test acid and base? We test it by a pH meter. This one, pH meter. There is about structure. I depend on Abbas and Safa for collecting pictures for this on the slides, and one day represents. So we will get some information. pH meter. We have pH scale. Okay. pH meter is just, it's a numeric by numbers. It's just a metal you inserted into a solution and it will display for us the pH value. This is what we mean by pH meter. pH scale is the colors, is like this color, yellow, red, orange, red, violet, and the green, and the blue, and its range is from 0 to 14, the colors. So we can exactly know the acidity of our solution. It's okay, it's acid, but even from the color of the scale, I can know exactly the pH of the solution. Third one, solution. This solution tell me only if I have acid or base. And this is mean change of the solution. For example, if I have phenolphthalein, this is a solution. Okay? And this has colorless. Colorless. When I add it to acid, it stay colorless. With acid, it stay colorless. With base, it give me pink color. Okay? With acid, it stay colorless. With base, it give us a pink color. Okay? The fourth one, it's litmus paper. Litmus paper, we have two types of litmus paper. Red litmus paper and blue litmus paper. When I was students in grade 7, this is the only one I know about it because our teacher show us this one. My teacher was my father in the grade 7. So he show us the red litmus paper who has a red color. When we dipped in acid, it stay red. And when we dipped in base, it turns blue. And he show us the blue litmus paper. When we dipped in acid, it turns red. But when we dipped in base, it turns blue. In base, it's a stay blue. Okay? So it's red with acid, but turns blue with the base. blue, it red, it blue with the base, it turns red with the acid. Okay, so either this or this, if the color of it red, this is mean my solution is acid. If the color of them blue, this is mean my solution is base. Okay, so this is, I don't remember if there is a fifth one. This is what I remember. Okay, and even when we do salad, do you know the red cabbage? Did you cook any time with the red cabbage?
Yes.
Okay, this red cabbage, do you recognize when we add lemon to our salad, what will happen?
Changes color
What to change the color?
of the cabbage.
No, it's the cabbage itself. It will start to make mess. My salad will start to have drops of this of the pink color, if you remember.
Maybe colorless.
Huh?
It's gonna start losing the color of the
Yeah, it
cabbage.
will make everywhere. It will start to be pink.
Miss, what is a lumen?
Lumen,
Yeah, you said lumen.
lemon. It's not
Oh,
lemon.
lemon. Oh, okay.
Lemon. It's which mean acid. I just when we add lemon to the salad, okay, especially if we have the red cabbage. Okay, I told you, Yusuf, today it's terrible. When we have red cabbage and we add the lemon, which is acid, okay, it will start to have a solution pink in that salad. Even if we have lettuce in it and a drop of pink color will be over the salad, wherever we have this acid solution, which is the lemon, it will start to change. When you do it next time and use the red cabbage, recognize red cabbage is one of the indicators, is one of the indicator. We call it natural indicator. We call it natural indicator. It shows us that our solution is acidic and it make the color of the solution that we have pink. Okay? So this is properties of acid. No, I didn't write it. This is how to test the acid. The title is not related to what is written. Did you recognize this, students? So I was talking about the property of acid, and I said, please write the properties of acid and then I said how to test how to test acid and base. Okay. So this is how to test acid and base. Now the third things, what is the definition of acid and base? Before we start testing, and we have to know what we mean by acid, what we mean by acid, what we mean by base. Okay, according to Arrhenius, according to three scientists, we are going to study the definition of acid and the definition of base. Okay, according to Arrhenius, what did he say? Arrhenius said, if a solution liberates H plus, the solution liberates H plus, so this is acid. If the solution give me OH minus, this means that my solution is a base. And this is what we know. For us, this is what we know regarding this. Okay, so this is the definitions that we know regarding the acid and the base. If my solution liberates H plus, this is mean my solution is acid. If my solution liberates OH minus, this is mean my solution is base. Okay? So what regarding the how to write the equation? Okay, I have HCl. It will dissociate or ionize, it will give me H plus plus Cl minus. Gave me H plus. Yes, so this is acid. So this is acid. It's so easy because because we know all the time we write it. So as you are explaining something, we don't need it. This is what Arrhenius said, and this is what they teach us from long time ago, that liberation of H plus will be, this is mean that this compound is acid. Liberation of H plus here, so it's mean it's acid. And another example, H2SO4. This will liberate 2H plus SO4, 2 minus. But even if 2H plus, it's okay. I have also phosphoric acid. Do you know phosphoric acid? Phosphoric acid. It will liberate 3H plus, which phosphate. This is number 3. Okay? And this is what they call it bi-acid. This is give me bi-acid. This is give me monoacid. This is tri-acid. Okay? So it's the liberation of how many H decide the type of this acid. This is what Arrhenius said. No.
No.
Arrhenius. This is the first scientist who defined for us the acid. The second scientist, okay, which is Brunestad Lowry. Brunestad Lowry acid-base theory. Okay, Brunestad Lowry acid-base theory. His definitions for the acid base. Brunestad defined the acid and base in a different way. He defined it according to donations and acceptance. And we know if I donate $5, this is mean there is someone who accepted. How you can call me a donor if there is no one who is a receiver, who is the acceptor of my donation? If I put this as $5 on the table and no one get it, so it will we cannot say it about a donation. Okay, so when we have donors, we should have acceptors. But how he defined it? He said, Brunestad Lowry, he said that H plus cannot stay like this in the solution. It never stay like this. When we just dissolve HCl in water, when we add HCl to water, this H plus combine with the water directly and give me H3O plus, hydronium ion. Okay, so I have H plus will react with water, it will give me this. And how this is for him, how the H plus should be look like. Because he said this is we cannot find it in nature. We cannot find it in the solution because it will react directly with water to give me H3O plus. Okay, so if I want to find the pH, we will find the pH for our solution. This is how we find the pH. It equal H plus. For him, we shouldn't write it this way. This is how Arrhenius write it. For Brunestad and Lowry together, they write it this way, minus log. Instead of H plus, because he said H plus is not there, it react with water, it give me H3O plus. So this is showing me the acidity of the solution. The presence of this means that my solution is acid. for Arrhenius, the presence of H plus, it's showing that my solution is acid. Here, the presence of H3O plus, it's showing us the acidity of the solution. What Brunster said? Brunster said, suppose you have anything, for example, chlorine with any compound, this chlorine, reacted with water. Okay? Which one we have to take first? Let's take it HCl. Which one is the acid?
The chlorine. The hydrogen.
HCl. The HCl. This is my acid. And this is my base. Okay? So I have acid. And we said Brunster Lorry talk about donations and acceptance. This is has H as H. And Brunster Lorry defined the acid as donor, He said H plus donor. So this is will donate H plus. And this is what we'll do. If this is donor, and there is no in this place except HCl and water. If HCl will work as a donor, water will work as what, Yusuf?
Sorry, so what's the question?
If HCl will act as a donor for H plus, so the water will act as what?
HCl with the water?
Will donate H plus.
Yeah, and what is water gonna be?
Yeah,
It's gonna be like mixed with the with the H?
with the
HCl?
yeah. And so she will be what? The one who accept.
Yeah.
Because we said if we have a donor, this is mean we have an acceptor. Can you be a donor without accepting? Without and if how
No.
you can call yourself a donor?
Yeah. No,
You
you
go
can't.
out-
You can.
If you are going out and you give money for somebody, okay, you are a donor. If you go out and you didn't find any person in the street or anywhere, can you be a donor?
No, because there's no one to give.
Yeah. You want to give, but you didn't find anyone to accept. So if no one accepts your donations, you are not a donor. Here at CL, it's a donor because water accept her gift. So because water act as acceptor. Okay? And then what will happen? If water accept the donation, what was the donation? Was H plus. When water accept the donation, it will look like this. It will be like this. Sorry, H3. And what about HCl will be? HCl will be Cl minus. Okay? What we call this about it? We will say about it the one who accept the donation. Okay? So it will be conjugate acid. It will be Ca. We will call it conjugate acid. Conjugate acid, the one who accept the donation. Is it understandable, this material? Because water accept the donation, okay, so we will call it the one who accept the donation of the acid. Conjugate acid, it's mean the one who accept the donations of the acid. Okay, ClO minus, ClO minus, half sleeping. CB, what we call it, conjugate base. This is what the meaning of conjugate base. This is the one that donate for the acid. Conjugate base is the one who donate to the acid. Conjugate acid, it's the one who accept the donation from the acid. Did you understand it?
Yes, Miss, I have a question.
Yeah.
So chlorine turned into a base after being an acid?
No, who said it's a base? I said it's conjugate base.
Okay, so it's still it's still a
It's still the acid that lose H plus. We cannot say about its acid. We say the acid that lose H plus. Okay? Or the one who to donate to the base H plus. We said conjugate base, which means the one who conjugate the one who donate
Mhm.
H plus to the base, the one who donate the base. For example, if we have a person, his name A, donate for a person whose name B.
Mhm.
Okay, so B now rich or have donations. This is B is the acceptor of the donations of A. Because of this, we call him conjugate A. Because he is the one who accept the donations from A. Okay, this is what we mean by conjugate base or conjugate acid. Conjugate base, this is the one who accept the donation from the acid. Or who the one who accept the donation, okay? Conjugate base, the one who donate to the base. Or the one who donate, the acid that make the donations. Or the one who donate to the base. It's still the same meaning. However, you change it, it's still the same meaning. Okay? But he gave donation. Okay?
Okay.
I will give another example. So this is Brunstad Lori. Brunstad Lori, he said this is about the acid. For example, if I have H3, BO4, with water. Oh, this is not, because acid will not. This is usually H3BO4, shows she is missing one H. It here will either give to the water or will take from the water. I want you to know that some compounds are amphoteric. They donate, they work as acid and base at the same time. They work as acid and base at the same time. Look at this. Do you see this equation? One time it will be the donor, the other time it will work as the acceptor. Okay? See how I will work on it. Now we will decide it to be acid. He will tell me in the question which one is the acid. Sometimes for me it's very hard to decide which one is the acid and which one is the base. Here it's very clear because HCl cannot accept. So it for sure she will be the one who donate. Here, this one is the can be acid and or can be base, but this time I will make it the acid. If she the acid, this is mean it will be H plus donor. So it will lose H and will be H4 2 minus because it's lost one more, so it's now 2 minus. Look at it. It has 2 H2. It has 2 H, but this doesn't mean it has to lose both of them. She lose every time only one H. So it lost one H. Who will accept it? H plus acceptor. Okay, so this is acid redonate to the base, so it's conjugate base. Plus, this is one accept the H, so it's conjugate the acid. Because why it's conjugate acid? Because she accept the donation from the acid. And that one, what it is conjugate base, because it donate H plus to the acid. Donate to the base, not to the acid. Did you understand it? I will give the third one, and I want you now to work on it. And even I didn't explain it, the same equation, but in another way. Please look at this. Wrong again. I wanted the same one. Okay, here this will be the acid. And here this will act as the base. Even it's not a base, but here because it want to accept. What will happen? This will lose the H plus. Acceptor. Think about it. Think about it. This will accept the H plus, so have to increase.
Miss, does it donate 2 H's?
H plus acceptor. This is H plus donor.
Oh, okay.
This is, do you see H3PO4? What about this? This is lost H plus. So it now H plus O minus, which mean OH minus. There is no. Okay, look how it look like. It's minus because it lost. This is conjugate acid. Okay, because the one who accept, this is conjugate. Yes. Okay, do you understand? I will give the last example and please work on it. Okay. Who will work on this, please? Who will work on this?
I can try.
Okay.
Would the H2O be an acid?
And H3 4 will be acid.
The H2O.
This one.
Yeah.
It will, yeah, because it will cannot accept anymore.
Okay.
So this will be the base. So how it will look like this one?
1 sec, I'm gonna write it down.
Okay,
This would it be NH5 plus
NH 3. It lost one.
uh
It lost already. Now plus H3 or plus. This is minus, not the plus. I will put a YouTube because the students look like they didn't understand. Okay, conjugate acid and conjugate base. The others. Just a minute, look at them. Please work out.
Miss, are we done?
Oh, son. Are you were with us?
Yeah, Miss.
No, I just said we'll display a YouTube because I feel you didn't understand.
and water.
Okay.
So hydrogen fluoride is
Please,
a
just
weak
it's
acid,
another
and when you
6
put it in
minutes.
water,
Listen to
it
it.
will dissociate.
Why the voice went?
It partially,
Oh.
so some of the HF will dissociate and you'll get fluoride minus ions. And then that dissociated H plus ion. So this dissociated H plus ion will get donated to our water. So water then becomes H3O plus or hydronium. And so this process is in dynamic equilibrium because it can go forward and it can go backward. And eventually those two rates are equal and they're both happening at the same time. So in this reaction, we have a couple things going on, and we're going to think about it in terms of hydrogen ions being exchanged. So if we just look at the hydrofluoric acid and we look in the forward direction, our HF is becoming F minus. And it's doing that by donating or losing. So I'll put a minus for losing a proton. So our HF loses a proton. That forms our F minus or fluoride ion. And then we can look at that same process happening in the backwards reaction. So if we look at the backwards reaction, which is also happening, the fluoride ion can pick up or accept a proton from somewhere. So it can pick up an H plus. So I'll have a plus, H plus here. And so when fluoride accepts a proton, we reform our HF. So we can see that HF and F minus have this special relationship where you can form one or the other by losing or gaining a proton. And we can see a similar relationship between water and hydronium. So water here, we said water is accepting a proton from HF. So we see that water will gain a proton, and that will give us hydronium.
Sorry. This is Khan Academy. I don't believe Khan Academy. I don't, I prefer chemistry, organic chemistry. He explained things in a better way. This is one is mixed the two theories with together. He mixed Lewis and he mixed Arrhenius at this, mixed Brunestad Lori at the same time. So this is will not helpful. It will make you feel confused. I stop it. Not the one that I told you I am not preparing my lesson well. So I have to prepare the video. I will upload it for you. This is no. Sorry, the video will not be helpful. It will make you feel confused. There is a video which is really very good. I will upload it, okay? But I like one thing is she said it. When we have HF and we have water, every time we see a YouTube or something, we learn something new. So this is will lose because it's donor. The donor lose H plus, okay? So it will be have minus because this is the minus is as negative that will show you us our loss. And this is will gain this H plus. This will be gained the H plus. You see plus H plus. So this plus will be here at the top of it. So this is beautiful things from it. Okay, from this video we can learn this good things that here plus H plus. So look, it's positive, and you add H, and you add the plus. Do you
Miss,
see?
is that H3O or H2O?
H3O.
Oh, H3O, okay.
Yeah, because see it was H2, and it gained H. So now it's H3O.
Oh, gain H from the left, right?
Hmm?
Yeah, okay.
Yeah, it's from the fluoride, hydrofluoric acid.
Oh, okay.
Okay, and this one will gain. So see, this one will lose. It will be like this. This is donor. The donor will give. Okay, this is acceptor. Acceptor of what? Please be careful. Donor of H plus. This is acceptor of H plus. Because this is what Brunster say. Lewis said it's donor and acceptor of electrons. This is donor and acceptor of ion. H plus and H plus here, it's ion. One donate the H plus, the other accept the H plus. Okay?
So we only donate hydrogens?
Only donate hydrogen.
Okay.
So because we either donate hydrogen or, for example, if I have Fi, and I added for it water, she cannot donate this. This is need help. She accept donation. Accept H plus. Okay, this is donate X plus. Okay. So HF plus OH minus. Why it's now OH minus? Why now it's OH minus?
Because it accepted.
Because it lost. This is minus H. We take from it H. So this is the remaining. And this is we added for its H. So this is the answer. The product is what will appear after we donate or accept. Iron here, fluorine here, has no hydrogen. So it's ready to accept any donation. So she accepted the donation and now she HF. While water donate the H plus, we will take away from it H and it will be OH minus. Okay. Are you understanding?
Yes, miss.
Okay. So now we will move to the third scientist and that's all. I will upload for you tomorrow a video and so you have to make it, but we have to agree on the PowerPoint before you're leaving. Okay? Lewis came to say something else. Lewis said, I will give you you search the differences between them, it give you a nice table. Lewis said, Lewis acid base theory. Bronsted said, it's what dissociation of H plus. Only dissociation, no donation. It's just dissociation of H plus in the solution, so it is acidic. If dissociate OH minus, it will be base. Arrhenius Lori came and said, if it donate H plus, so it's a donor. And it will be the acid. And if she accept the H plus, so this is acceptor is the base, okay? Always the acid is the one who is donor, okay? Arrhenius donate as H plus is acid. Accept H plus is base. Lewis said no. Donate. We said this is ion. Remember what we call this as ion. Ion. This one donate electrons. Said the one who donate electrons is not acid. Not every time is the acid the donor. The one who donate electrons is the base. The one who accept the electrons is the acid. Okay, regarding the Lewis, I just need this. I want you only to know what is doing. Regarding the Arrhenius, you have to know who is the donor, who is the acceptance, and also how to write that equation and decide which one is the acid, which one is the base, conjugate acid, conjugate base. Okay?
Okay.
Is the lesson clear, ya Ali? Hello, Ali? Ali is not here.
Yes, miss.
Did you understand?
To be honest, so. I'm a bit like
wasn't
confused.
here, ya Ali. We wasn't here.
I was.
What you didn't understand?
So like for this app, how did you like get all of this?
What about
Like
all
I'm
of
a bit confused. Like you see on page 1,
what?
so you see F minus plus H2O equals HF plus OH minus.
Okay.
Yeah, so like how did you get it? Like I'm a bit confused on that one.
This equation we wrote it and then we looked at it. HF cannot accept anymore. So she is ready to donate. And it's an acid. The acid always is the donor.
But how do you know if it can't accept anymore though?
We've tell you which one is the acid and which one is the base at the start. Okay? But
So
because
you already
HF is satisfied. HF is satisfied. As HCl. HCl can accept anymore.
okay.
HCl can accept.
Uh,
No,
yeah,
no,
no.
cannot accept. They prefer these strong acids, prefer to give. To
So
give
if it can't accept, it's gonna give.
what?
So if it can't accept, it's gonna give.
If there is a chance to accept, it give.
No. Like if it can't accept,
Ah, if she cannot accept, so it for sure it will give. If it's in acid state.
if it's okay.
Yeah, not if a salt.
Oh,
It
okay.
contains H. If it contains H, because here we are studying acid and base only.
Okay. But like we will know which one can accept and which one can't accept in the question itself. It will say, right?
Yeah, but do you know who can accept? Usually the one who accept, I will add for it H and put minus or plus. For example, water. Do you see water plays two roles. Once it accept H plus, it will be H3O plus. And another time it donate H plus. So it will be what? O H.
Okay.
Okay, so Arrhenius, we have to study the donation and the acceptance of the H plus.
I have a question.
Yeah.
So is there will be a video posted about this?
Sorry, what did you say?
Like a video posted about this? Like you know how every time you put a YouTube
Oh no,
video?
I will post tomorrow morning.
Okay, yeah, no problem.
I will post this and the video related it.
Okay, no problems.
It's easy question. This is the question that students get from ITMAR. Okay, any question till now? San, understand. Ali,
Yes, miss.
yes. Did you understand?
Yeah, now understood. Thank you.
Yusuf,
Yes, miss, I understand.
Safa,
Yes.
Abbas, San.
Yes, miss, I did understand it.
And who's still here? Okay. So you can leave. I cannot anymore, to be honest. I am very tired. I cannot focus. It's not easy for me to explain.
Okay,
Okay,
Miss.
No.
Let
Sorry.
you.
Sorry, really sorry. Okay? See you on the Tuesday at 6, inshallah, okay?
Miss
And
Tuesday or Wednesday?
huh? Can we
Is
make
it?
it can we make it a Tuesday?
I don't think
Sure.
I don't think I
Yes,
can.
for the
because
available.
Who cannot a Tuesday?
I cannot
Abbas.
because it's like the
Okay,
second day of
okay,
Christmas.
okay, Wednesday. Oh, before you leave, Abbas and Safa, they are okay. They have the acid.
Yes.
Other group, Yusuf, Ali, and San.
Yeah,
Uh,
we can do it
Can
together.
you think about the chemical equations, about whatever we studied, solubility, about the chemical equations and the solubility? Are you okay with this part?
Yeah.
Okay, Ali?
Yes. Okay.
Okay. So make the your presentation colorful or beautiful. I will post everything related it tomorrow and even the table that your name's on it. Okay?
Okay.
Ali,